In this video, we're going to talk about the flow-oriented elements of the analysis model. Now, these flow-oriented elements are not really represented that well in the current version of Pressman's text. And I think that's unfortunate because the data flow diagram is one of the few diagrams we're going to talk about here that is not part of the unified modeling language. And yet it's still fairly popular in development and can even be used in agile development. Here's an example of a level 0 data flow diagram that is going to be used to represent the safe home security function. The bubble in the middle represents the system, and the squares to the left and to the right of the bubble represent external entities in our system that provide input and receive output: the control panel, sensors, alarms, and the telephone line. Finally, the arrows represent the data and the direction it flows in the system. Notice that for the external entities on the left of the system, the control panel and the sensors, data is flowing toward the system. So these represent external entities that provide input to the system. For the external entities on the right, the display, the alarm, and the telephone line, the system is going to send them its output. The really interesting thing about the data flow diagram is how it can be refined. This is a level 0 data flow diagram, also called a data flow context diagram. What we're going to do is refine all the bubbles in the data flow diagrams until we get to a point where the bubbles are cohesive processes. That means that they're processes that have a single well-defined task. Once we reach that point, those processes can become functions or methods in the implementation of our system. Here are some guidelines for the data flow diagram. We depict the system as a single bubble in the level 0 diagram, as we've already seen. We note the primary input and output, label everything with meaningful names, and we refine each diagram that we create by elaborating the bubbles. An important part of this process of refinement is maintaining information conformity between the levels. It's easier to show you what this means rather than trying to explain it without the diagram. So let's go back to our level 0 data flow diagram. As we can see here, the primary inputs and outputs are given and everything is labeled. Our task now is to refine that main bubble. And the way we do this is by using the text-based description of what the security function should do. We obtain this text-based description during requirements gathering. Okay, so let's look at this description. Here we see 4 paragraphs describing the safe home security function. We have 4 different elements in a data flow diagram. We have boxes that represent the external entities. We have bubbles that represent processes. We have arrows that represent data. And we have open-ended rectangles that represent data stores. Now, data stores do not appear in the level 0 data flow diagram, but they will appear in our refined diagrams. The way we're going to obtain these elements is by doing a grammatical parse of the narrative. A grammatical parse simply gives you the nouns and the verbs in a piece of text. Those nouns and verbs are then looked at to see if it makes sense for them to become an element in your diagram. So this is not something that's a completely straightforward process. You have to think whether a noun or verb makes sense as an element within the context of the system. Before we get started with this, I'd like you to take a moment and think about the 4 different kinds of elements that we talked about: external entities, processes, data, and data stores. and see if you can tell me whether a noun would be a candidate to become a specific entity or whether a verb would be a candidate to become that entity. Okay, let's look at these one by one. First, to find external entities, we should be looking at nouns in our system. Homeowner, control panel, sensors. To find processes, we need to be looking at the verbs. For example, invoking an alarm or dialing a telephone number. These things will likely become processes in our level 1 data flow diagram. Okay, what about data? Data is represented by arrows, and because it's represented by arrows, a lot of students incorrectly think that we should be looking at actions for these, which are verbs. However, the arrows are simply indication of the direction of the data movement. The data itself is indicated in the narratives by nouns. For example, user commands, sensor status, password, information, all of these are nouns. So we look for the nouns in the descriptions to help us to figure out what the data should be, not the verbs. Finally, data stores. This one is a little bit tricky. I can imagine seeing something in a description that says information is written to the hard drive or stored in a database or saved in memory. In this case, hard drive, database, and memory are all nouns. But sometimes you may see a sentence like, the video from the camera is recorded and can be played back later by the homeowner. Well, this doesn't mention a specific data store, but it implies, through the use of the verbs recorded and played back, that some data store must exist. So I think you really have to look at certain kinds of nouns and certain kinds of verbs to understand where and when you have a data store in your system. Okay, let's take a quick look at the nouns and the verbs in the description of our surveillance function. Remember, nouns can potentially become external entities, data, or data stores. In the first paragraph, homeowner, PC, and control panel look like external entities. In the second paragraph, number, type, password, telephone number, and sensor event, these all look like data. I don't see anything here that looks like a data store, but I do see something called configuration activities. And usually, if you configure something, you're going to have to save or store that configuration information. So you're probably going to want a data store for that. There are more entities and data here than I just mentioned, and you can feel free to pause the video and look at each noun to see if it makes sense to use as an entity or as data. Some of them clearly do not, like security function and installation. But I'm going to move on to the verbs. Okay, let's look at a few of these verbs. In the first paragraph, enables and interacts don't really seem like good processes, but configure and monitors seem plausible. In the second paragraph, I like arming and disarming and dialing. Other verbs that catch my eye here are invokes and displays. Remember, this is not a perfect process. What you decide to put in your diagram may not be the same as what someone else decides to put in their diagram. However, there should be certain similarities. Let's take a look at an example level 1 diagram, and I'll talk about what I mean by that. Okay, here's the level 1 data flow diagram. What we've done here is refine the single bubble in the DFD context diagram. And remember, the context diagram is another name for the level 0 data flow diagram. So one bubble has become 6 bubbles plus a data store. The 6 bubbles are interact with user, configure system, activate, deactivate system, process password, display message and status, and monitor sensors. The data store saves the configuration information. To better see what's going on here, let's find a path to trace through the system from input to output. For example, from the control panel, the homeowner inputs their username and password. That information is going to be part of the user commands and data arrow in this diagram. The information goes through the process interact with user. It's determined that a password has been entered, so the password information is sent to the process password process. That process sends its result to the display messages and status process, which then sends the information to the control panel display. Let's do one more. Suppose one of the sensors is triggered by an event. The sensor sends the status information to the monitor sensors process, which determines that a sensor event has occurred. It sets off the alarm and dials the number of the monitoring service. Remember that one of the things we talked about was maintaining information conformity between layers. Let's bring back the level 0 data flow diagram to better see what this means. Information conformity means that the inputs and outputs of the processes you are refining do not change. So we're refining the system process, which, as you can see, is the only bubble in the level 0 diagram. The inputs and outputs to and from this bubble all begin and end with external entities. Since we're refining the bubble, every new process and every new data store in the level 1 diagram is inside the system process in the level 0 diagram. And this means that the data coming in from external entities is the same in both diagrams. And the data going out to external entities is also the same in both diagrams. For example, the external entity sensors provides sensor status in both diagrams, and the external entity alarm receives alarm type information in both diagrams. Let's take this one step further. Suppose we decide now that the process monitor sensors needs to be further refined. In this level 1 diagram, the monitor sensors process receives two pieces of information. It receives sensor status from the sensor's external entity, and it receives configuration data from the configuration information data store. Meanwhile, it provides three pieces of information. It provides sensor information to the display messages and status process. It provides alarm type information to the alarm external entity. And it provides the telephone number tones to the telephone line external entity. In this level 2 diagram, you can see that the same pieces of information are coming into the process, sensor status from the sensors and configuration data from the configuration information data store, and the same pieces of information are going out of the process. Sensor information to the display messages and status process, alarm type to the alarm, and telephone number tones to the phone line. Keep in mind that this is not optional for a data flow diagram. This is information conformity, and you must maintain information conformity throughout your levels. Okay, there's one last piece of information I want to remind you of. Do you remember when we are supposed to stop refining the bubbles or processes in a data flow diagram? I won't ask you to pause the video for this, but I will give you 10 seconds to try to find it in your memory if you've not done so already. 10 seconds starting from now. Okay, when the bubbles or processes reach the point where they do one and only one thing, meaning they are cohesive, they no longer need to be refined, and those processes can become functions in your implementation. By the way, think about what that means if this whole thing really works in an ideal situation. It means that you can trace the functions in your code all the way back to your requirements. And that, again, if it works, is a very desirable property. I wanted to leave you with this slide because when data flow diagrams were more popular before UML and object-oriented languages came along, they were often paired with control flow diagrams. Control flow diagrams were essentially state diagrams. They showed how the system transitioned from one state to another based on external input. Control flow diagrams had different syntax than the state flow diagram you see here, but they serve the same purpose. We'll talk more about state diagrams in a later video. And that concludes this video on flow-oriented elements, and specifically on the data flow diagram. I hope you found it interesting, and I'm a bit disappointed that Pressman de-emphasized it in the latest edition of his text. Okay, I'll see you in the next video where we will discuss class-based elements.